Dear students, in the previous video, we were discussing the activity given in your book at page number 86. We have done this activity up to question number 2, part number D. Right? Now, we will continue from question number 2, part number E. Here again a name is given which is a wrong name, and we are asked to write the correct name and indicate what is the mistake in this name. Right, students? So first of all, we will write the structure of this given name. What is the parent chain, students? Here the last part of the molecule is the parent chain, pentane, right? So we made a carbon skeleton made up of 5. We made the 5 carbon skeleton: 1, 2, 3, 4, 5. Then we do the numbering by any way, either from left side or either from right side. 1, 2, 3, 4, 5. Right, students? Now here in this name we notice there are 2 ethyl. 2 ethyl radicals are attached, right? What are their position? One ethyl radical is attached with carbon number 2 and the second ethyl radical is attached with carbon number 4. So here we made one ethyl radical with second carbon, CH2, CH3. And the next ethyl radical with carbon number 4, CH2, CH3. We attached both the radicals. Now fill the vacant vacancies of carbon with hydrogen. 1, we add 3 hydrogen to make this carbon tetravalent. 1, 2, 3, we add 1 hydrogen here. 1, 2, we add 2 hydrogen here. 1, 2, 3, we add 1 hydrogen. 1, and here we add 3 hydrogen to make this carbon tetravalent, right? Now after that we find the parent chain. Here this straight chain consists of 5 carbon. Now 1, we find another parent chain: 1, 2, 3, 4, 5, 6, 7. This chain consists of 7 carbon atoms. 1, 2, 3, 4, 5, 6. So this chain consists of 6 carbon atoms. So which chain is the longest chain, students? Yes, of course, the carbon chain which is made up of 7 carbon atoms. Once we find the parent chain, we enclose the parent chain in the box like this. Here, enclose the parent chain in the box, students. Right? Now do the numbering of the parent chain. We do the numbering. If we do the numbering from this end, 1, 2, 3, 4, 5, 6, 7. If we do the numbering from this end, here we notice there are 2 alkyl radicals which are present outside the chain, right? Now their positions, here students you can notice what is the position of this alkyl radical. If we do the numbering like this way, one alkyl radical is attached with carbon number 2, right? And the second alkyl radical is attached with carbon number 5. If we do the numbering like this way, 1, 2, 3. At the third carbon, we have one alkyl radical. 1, 2, 3, 4, 5. With 5 carbon, we have another alkyl radical. Right, students? So compare these numbers. Which numbers are lower? Yes, of course, 2 and 5, they are lower number. So this is the correct way of numbering, right? Now assign the correct IUPAC name to this molecule. What is the correct name, students? How many methyl radicals are there? There are 2 methyl radicals. So we use the term dimethyl. Dimethyl. Now before writing dimethyl, we must specify their positions. One methyl radical is attached with carbon number 2 and the second methyl radical is attached with carbon number 5. So its correct name is, we write the correct name here, 2, 5 hyphen dimethyl. And what is the name of parent chain? The parent chain made up of 7 carbon atoms, so that's why name is started with hept. All carbon atoms are connected with single bond, so ane is used as suffix. 2,5-dimethyl heptane. This is the correct name. Got it, students? This is the correct name. Right? So what is the mistake in this name? Here the parent chain is not correct. Parent chain is not pentane, it is heptane. I hope this is clear to you. Now from question number 2, the last part which is left is part number F. Right, students? So here another molecule is given to us, 3-ethyl 4-methyl pentane. This is the wrong name and we are asked to write the correct name. As usual, we will see what is the name of parent chain, pentane, right? So we made the skeleton of 5 carbon atoms, 1, 2, 3, 4, 5. Now do the numbering by any way, either from left side or from right side. 1, 2, 3, 4, 5. Right, students? Now attach the radicals. At the third carbon we have ethyl radical. Which is the third carbon? This one. So we have ethyl radical with carbon number 3. Ethyl radical made up of 2 carbon atoms, CH2, CH3. With carbon number 4 we have methyl radical, CH3. Right? We attached both the radicals. Now fill the vacant vacancies of carbon with hydrogen. 1 plus we add 3 hydrogen. 1, 2 plus 2 hydrogen. 1, 2, 3 plus we add 1 hydrogen. 1, 2, 3, 1 hydrogen. 1 plus 3 hydrogen, 4. Right? Now find the parent chain. This is the chain which is made up of 5 carbon atoms. Now find another chain. 1, 2, 3, 4, 5. This chain is also made up of 5 carbon atoms, right? So we are asked to indicate the mistake in this name and write the correct name of this compound. All right, students. So this is the correct way. We find the parent chain here. Right? Now we do the numbering again. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right, students? If we do the numbering like this way, then there are 2 radicals, this radical as well as this radical. Methyl radical is attached with carbon number 2, right? And ethyl radical is attached with carbon number 3. But if we do the numbering like this way, 1, 2, 3. With the third carbon we have radical and 4, 5. Another radical is attached with carbon number 5. 1, 2, 3. With third carbon we have 1 radical, 4, and with 1, 2, 3, 4. With 4 carbon we have another radical. Right, students? So now compare these numbers. 2, 3, 3, 4. Of course, 2, 3, these are the lower numbers. Right? Now assign the correct name to this molecule. This is 2, 3 hyphen, right? All right, students, here we have two different radicals. One radical is methyl, another radical is ethyl. We have different types of radicals, so we must follow the alphabetical order, right? Ethyl should be written first. Whatever is the position of ethyl on the parent chain, it should be written first. So what is the position of ethyl? Ethyl is attached with carbon number 3. So we write 3 hyphen ethyl hyphen. What is the position of methyl? 2 methyl. And what is the name of parent chain? It is made up of 5 carbon, so it is pentane. So what is the correct name of this structure? 3-ethyl 2-methyl pentane. Right, students? This is the correct name. Now, what is the mistake in this name? Here, methyl. For methyl, 4 position is not correct. Right? Methyl is attached with carbon number 2 instead of carbon number 4. That's why this is a wrong name. I hope this is clear to you. Now we have done question number 2 of the activity given at the page 6. After that, question number 3 is given to us. What is the question, students? Let's see. Write the structure of the following compounds. Here the common names are given and we are asked to write their structures. Right, students? Now we are starting. First one is Neoheptane. If Neo is written before the name of compound, Neo shows all the 4 valencies of carbon, they are filled by alkyl radicals. If all the 4 valencies of carbon filled by alkyl radicals, then we use the term Neo, right? Here total carbon atoms are, Hept shows total carbon atoms are 7 and Ane shows all the 7 carbon atoms, they are linked with the help of single covalent bond, right? Now starting this name, we write 1 carbon and we fill this carbon with alkyl radical. Simplest alkyl radical will be methyl on here, one side, methyl and methyl here, right? Count the number of carbon atoms. 1, 2, 3, 4, 5, 6 and 7. 1, 2, 3, 4, 5, 6, 7. This is heptane. Right? This is the common or trivial name. Here with this carbon we have all the valencies, 4 valencies of this carbon atom is filled with alkyl radicals, right? Here one alkyl radical, second alkyl radical, third alkyl radical and fourth alkyl radical, R1, R2, R3 and R4. All the 4 valencies of carbon are filled by alkyl radical. That's why we use the term Neo. Got it? Now see the next name. Iso-heptane. Iso shows there is a branch in the compound. Hep shows total carbon atoms are 7 and Ane shows all the 7 carbon atoms, they are linked with the help of single covalent bond, right? So we made the skeleton of iso-heptane, right? Anywhere we made a branch like this, branch is not connected with first or last carbon. It means with starting carbon or with ending carbon. If we write branch with starting or ending carbon, then it would come in continuation and becomes a part of parent chain, right? So we will not attach branch with starting or ending carbon. For example, we attach a branch over here, right? Total carbon atoms must be 7. 1, 2, 3, 4, 5, 6 and 7. 1, 2, 3, 4, 5, 6, 7, right? This is the structure of iso-heptane. Iso shows there is a branch in the compound. Hept shows total carbon atoms are 7, and ane shows all the 7 carbon atoms are connected with the help of single covalent bond, right? Got it, students? Now next is trimethyl ethyl methane. Another name is given to us and we are asked to draw the structure. Trimethyl ethyl methane. Now here meth shows how many carbon atoms are there, students? Yes, 1 carbon. So we made 1 carbon. Trimethyl shows there are 3 methyl groups. So 1 methyl group, we attach 1 methyl group here, CH3, 1 here, CH3, and 1 methyl group over here, CH3. We made trimethyl. Then ethyl, on one side we made ethyl group, CH2, CH3. Right, students? So what is the name of this molecule? How many methyl? 1, 2, 3. Trimethyl, ethyl, trimethyl, ethyl, methane. Right? This is the structure of trimethyl, ethyl, methane. I hope this is clear. Alright, students. Now see the next structure. Another compound is given. Dimethyl, ethyl, isopropyl, methane. Right, students? So here you can notice methane. We made single carbon. Right? Dimethyl shows with this carbon we have 2 methyl groups. CH3, CH3. Right? Ethyl. On one side we made ethyl group, CH2, CH3. Right, students? And isopropyl. Dear students, you know very well, we have 2 types of propyl. If a propyl radical is made up of like this, CH2, CH2, CH3, then this propyl is known as normal propyl, that is N-propyl. Right? But if with this carbon we have 2 methyl groups like this, CH3, CH, CH3. Right? So if with single carbon 2 methyl groups are attached, then nature of this propyl is isopropyl, since there is a branch, isopropyl. Isopropyl radical, right? So with this carbon we made isopropyl here, CH, right? CH3 and CH3. You can notice, students, here dimethyl, 1 methyl, 2 methyl, dimethyl, ethyl, ethyl, isopropyl. This is isopropyl. Dimethyl, ethyl, isopropyl, methane. Single carbon compound, right? And forming the single covalent bond with all the alkyl radicals. This is clear? Alright, students. Let's see what is the next. Another name is given and we are asked to draw the correct structure of dimethyl, propyl, ethyl, methane. This is the name, parent name of the molecule, methane. So we made single carbon here, right? Now dimethyl. Dimethyl means we made 1 methyl here and 1 methyl here, right? Then on one side we will write propyl, propyl radical. Propyl radical is made up of 3 carbon atoms. So CH2, CH2, CH3. We made propyl. And on other side we have ethyl. Ethyl is made up of 2 carbon atoms. This is ethyl. Right, students? Now you can notice here dimethyl 1, 2, dimethyl, propyl. This is propyl, ethyl. This is ethyl. Dimethyl, propyl, ethyl, methane. Got it? Now the last part of question 3. 3-ethyl hexane, right? Hex shows 6 carbon atoms. So we made 6 carbon atoms. 1, 2, 3, 4, 5, 6. Do the numbering. One, 2, 3, 4, 5, 6. Right, students? Now with third carbon, ethyl radical is attached. We attach ethyl radical with third carbon, CH2, CH3. Right? Now fill the vacant vacancies with hydrogen. Here we have 3 hydrogen, 1, 2 plus 2 hydrogen, 1, 2, 3, we add 1 hydrogen, 1, 2, we add 2 hydrogen, 1, 2, we add 2 hydrogen, 1, we add 3 hydrogen, right? So this is the structure of 3-ethyl. At the third carbon, we have ethyl radical. This is the ethyl radical, right? So what is the structure of molecule? 3-ethyl hexane. I hope this is clear to you.